Envisioning our radiant lunar future, a nuclear-powered colony. Imagine a future where humanity thrives not just on Earth, but also on the celestial body closest to us, the Moon. As we ponder the marvels of space exploration, a nuclear-powered moon base could be the pinnacle of human ingenuity. September 10th, 2025, 8 a.m. ET. Listen 1.0x. Listen to more stories on the noaa.com/offer ID @reader exclusive JKS1KJL. In a surprising twist, the Trump administration has shown a keen interest in alternative energy sources. Under the guidance of NASA's interim leader, Sean Duffy, the agency is set to embark on an ambitious project, placing a 100-kilowatt nuclear reactor on the lunar surface by the end of the decade. This move is not a mere win, but a strategic decision that recognizes the critical role nuclear power will play in sustaining a permanent human presence on the Moon. And this lunar base might very well be the most awe-inspiring milestone in space exploration for generations to come. For over half a century, the Moon has remained a silent witness to robotic missions, with human footprints last gracing its surface in the 1970s. However, the tide has turned, with President Donald Trump taking inspiration from the visionary Elon Musk. Plans to rekindle the American lunar legacy seemed uncertain. Musk's preference for a full-throttle mission to Mars put the Moon on the back burner. Yet, recent developments have seen a shift in priorities, as congressional Republicans have successfully secured increased funding for the lunar program, breathing new life into the dream of a moon base. NASA astronauts are now slated to return to the Moon in 2027, with regular visits planned from the early 2030s onwards. Each mission will contribute to the gradual assembly of a small but growing base, capable of supporting a limited number of inhabitants. Accompanying the astronauts will be a pair of vehicles designed for exploration, a compact rover for short excursions in spacesuits, and a larger, pressurized vehicle that allows for extensive 500-mile journeys across the Moon's rugged terrain, all while the crew remains comfortably dressed in street clothes. Compared to the exclusive ventures on Mars advocated by Musk and his followers, a lunar base offers a more inclusive experience. With shorter travel times, a broader range of individuals will have the opportunity to explore the Moon's stark and mysterious landscapes. Communication delays with Earth will be mere seconds, unlike the minute-long delays experienced from Mars, making interactions with loved ones back home feel almost instantaneous. However, sustaining life on the Moon presents significant challenges, particularly regarding energy supply. Temperatures plummet to frigid lows of -410 degrees Fahrenheit in the shadows, demanding robust heating systems to keep the inhabitants warm. Solar power, effective on the International Space Station, is insufficient for most lunar locations due to the prolonged 14-day night cycles. To address this, NASA employs plutonium-powered systems in its extraterrestrial missions, such as the Mars rovers and probes to the outer planets. These systems harness the heat generated by plutonium to produce electricity, a necessity for the Voyager spacecrafts as they drift further from the Sun. For a lunar base, a simple plutonium source won't suffice. A reactor capable of atomic fission, similar to Duffy's proposal, is essential. Unlike terrestrial reactors, a potential failure on the Moon poses less risk to human life. The Moon's already radiation-heavy environment and lack of atmosphere mean that hazardous materials would remain localized, falling harmlessly to the lunar surface. Duffy's push for the reactor's installation is driven by national security concerns. The Artemis program, NASA's initiative to return to the Moon, is a collaborative effort involving multiple nations. However, when the invitation was extended to Russia, Vladimir Putin declined, opting instead to collaborate with China on a more substantial lunar base, complete with a nuclear reactor 10 times more powerful than Duffy's proposed model. Bhavya Lal, a former NASA associate administrator under the Biden administration and current professor at Rand, along with aerospace expert Roger Myers, recently published a report. https://static1/squarespace.com/static1 16489-498-5 pf. Warning of the potential for a country to establish sovereignty on the moon by constructing a nuclear reactor, thereby circumventing the Outer Space Treaty. China could potentially enforce a safety buffer around its reactor, effectively restricting American access to valuable ice-rich craters. This scenario seems to have caught the attention of the current administration, evident in Duffy's directive to develop the reactor, explicitly referencing the identified risk. If the fear of Chinese territorial expansion on the moon serves as the catalyst for establishing a lunar base, it's a silver lining. Space exploration frequently necessitates geopolitical incentives. Should NASA succeed in creating this initial lunar settlement, the groundwork will be laid for more expansive bases capable of accommodating dozens, if not hundreds, of people. These bases could rival the scale of existing Antarctic research stations. There are even reports of space agencies exploring the possibility of constructing hydroponic greenhouses and intricate structures within the vast caverns beneath the Sea of Tranquility. Such infrastructure could pave the way for both positive and negative outcomes. On one hand, the moon could transform into an industrial wasteland dotted with mining operations, extracting precious metals for high-tech applications on Earth. Alternatively, the Outer Space Treaty could collapse, leading to a militarization of the lunar landscape, possibly even serving as a launch pad for nuclear arsenals. On a brighter note, an inhabited moon could serve as a shared scientific haven. Both the U.S. and China have conceptualized massive radio telescopes on the moon's far side, shielded from Earth's radio interference, significantly enhancing the search for extraterrestrial civilizations. In one design, robots would unfurl a metallic mesh from the crater's center to its rim, converting its bowl-like shape into a natural radio dish. One can envision an astronomer stationed at a lunar base, gazing through a porthole at the Earth, discerning its distinct oceans and continents, while on the moon's opposite side, a colossal ear listens intently for signals from other worlds, spanning the Milky Way and beyond.